Welcome to Build with Naz. My name is Naz. I'm the founder of Rebel and the author and maintainer of the Rebel 2e crate. I recently did a live coding video the last time where I actually walked through how to use nom and illustrated with lots of examples. Here's the blog post for that. And this week, and then I mentioned at the end of the video that the real parser that is in production that uses this type of sort of approach is the Markdown parser. And I said that I was going to go fix a bunch of bugs in there. Well, it's been a week and I fixed a bunch of bugs and decided it was time to do a video on how nom can be used to build a production grade parser, because there was a lot of things that I encountered, especially in the runtime behaviors, or just how to structure your logic or what the mental model is around how to use combinatorial parsers. It's very functional programming-esque. And a lot of that wasn't obvious from the sort of getting to know nom, which is important. I think it's extremely important to know the fundamentals and the types and, like, for example, the parser trait and so on. But I think that beyond that, to actually build a real parser is even more work. And so in this video, I'm going to walk through the design decisions that I made and also the architecture of the Markdown parser, which is open source. It is actually in this Rebel Open Core repo. So I'm the author and maintainer of Rebel Open Core repo, which inside of it has a whole bunch of crates. So we have like a lot of crates. Oh, I'm not logged into this. There we go. There's like Rebel Commander, Rebel 2FI, Rebel 2e, and a whole bunch of other Rebel Terminal Async and Rebel ANSI color. These are just some of the crates that are published as part of this monorepo. After recording this video, I'm actually going to launch a new version of Rebel Commander, which actually has a Markdown editor called Eddy, where all this code will actually be in production and live for you to play around with. And like I said, the source code is available on GitHub, and I'm going to be going through that in this video. So it's not a live coding video like the ones I've done in the past, but there is going to be quite a bit of code, and I will run a bunch of code and run a bunch of tests and show you the output and how things are put together. So I guess it's a coding video, but not necessarily live coding like the ones in the past. And then let's see. Oh yeah, and there's a documentation for that. So let me get started with the Markdown parser. Let me actually show you what this thing does. So Eddy is this a Markdown parser which actually uses this Markdown editor component. So Eddy, you can get that by saying cargo install Rebel Commander, and then that will go get the latest version of Rebel Commander, which has Eddy and giti. Giti is a tool that makes it easy for you to do. It's kind of like a helper for Git, and Eddy is just a straight up Markdown editor, and it's very pretty Markdown editor, as you can see. So it has lots of interesting things like let's start from the top, like colorized headings. It has smart lists, as I call them. It has really pretty formatting for hyperlinks. It even has like syntax highlighting instead of fenced code blocks. And I don't have table support yet. That's something that I'm planning to add in the near future. But yeah, this is Eddy. You can get this right now from Cargo, from crates.io. And so, and as you can see, even the theme that Eddy uses is custom, so it's all very pretty. Okay, so that was a quick sort of whirlwind demo of Eddy. Eddy's in an older release right now, and it doesn't have all the bug fixes that have gone into the basically reworked and rewritten Markdown parser. Like more than half of it is rewritten. So I'm going to release that later on today. But this is let me show you this. So when you clone this repo, the Rebel Open Core repo, to your computer, you can go to the 2e folder, and inside of the 2e folder you will find a very large new shell script called run. So essentially, because this is a monorepo which houses It has a workspace at the top level, which has, let me show you this. There's the cargo toml. This is for the monorepo, these are all the crates that comprise this workspace. So there's quite a few of them. The one that we're looking at today is this thing called TUI. So here, once you go to the TUI folder, once you've cloned this repo to your computer, you will find actually in every one of these crates and the top level project, you'll find a run script. And this run script is actually a new shell script. And this script also runs in CI/CD for this particular repo. And it's just like a sort of a hub. So you can say new run or just run if you have new shell as your default shell. And basically it'll tell you, what you can do with it. So let's run that again. It'll say, you can say new run, and then you give it a command and some arguments. So you can say new run build, new run doc, examples, and you can even watch tests. So this is pretty extensive. It even has information about how to do flame graph profiling, with a link to a video on what flame graph profilers are and how to use it for this particular project, which is really cool. So let's say that I want to show you how this Markdown parser works. So so I say new run examples. This runs the examples in this particular repo. And then number 3 example is the one that's of interest. This one is basically showcasing the Markdown editor component in isolation. This is not a part of an application, it's just an example. So this particular Markdown parser is the thing that I'm going to be showcasing today. Like how does this happen? There's actually 2 pieces to this. One is the rendering, which we're not going to cover today. I'll do other videos on this in the future, but this is more the parsing side. So for example, the actual Markdown content is just an array of bytes as loaded from a file, let's say. And so all that has to be transformed into, that's a string slice, and all that has to be transformed into an abstract syntax tree where information like, okay, this is a tag, or sorry, this is a title, this is a tag, that's an author, this is a date, these kinds of information or data has to be parsed from the string slice. So things like, okay, this is a heading 1, this is a heading 2. Now the formatting of this is not we're not going to cover that in this video because there's a whole other thing about. This is the parsing aspect. We take a string slice and parse it into essentially a DOM. For those of you that are familiar with web programming, but I didn't call it DOM. I just called it MdDocument, I think, and I'm going to go through all that in detail today. And then, so essentially this is the part where that string slice gets turned into the DOM equivalent, which is MdDocument, Markdown document. And the MdDocument has a bunch of nodes inside of it, or elements, and it's a tree of nodes. And those nodes or elements have information about whether basically what each line is. Sometimes they have information about more than one line, but roughly you can think of it that way. So there's something called a heading, there's something called heading 2, there's bulleted lists, numbered lists, there's fenced code blocks. So for example, if you put TypeScript, then this is formatted differently than if you put JavaScript. Then if you put, actually, I wonder if this, I don't think it has TypeScript support. So you can do JS, or you can do like Java, or whatever it is. And then the syntax highlighting will be different. And that's using something called syntect, just for the fenced code blocks. But the Markdown parser does parse this string slice and say, inside of here we have a fenced code block and the language is Java. So that's the kind of thing that this parser does. These are smart lists with to-do items. So there's a whole host of interesting things that are actually in this Markdown parser. Things like, okay, there's a list, and inside of the list you have a bunch of different lines, and one of those lines has a URL in it, so hyperlink. So this one is an example of a list, and inside of that you have a hyperlink, and another line you have an inline code block. So these are all the kinds of things that have to be parsed. That's the function of this parser, is to go through all of that. So yeah, check out this example as part of the Rebel TUI project. And then so yeah, it's you can just say new run examples and then type 3 and hit enter. So with that out of the way, let me jump right into the code and tell you or give you a sense of how this is put together. So the first place we want to begin our journey is, and actually ended up writing quite a bit of documentation and cleaning up a whole lot of the code and also making sense of what was there. There's a whole bunch of tests we're going to go through today to give you a sense of how to kind of get a feel for this parser. If you want to make changes to it, if you want to use it in your own projects, then this is a great starting point. And if you do want to use it in your own projects, let me know in the Discord or on GitHub. Create an issue in this repo, and I'll be glad to separate this parser out into its own top-level crate. Right now, it's part of the Rebel 2e crate, but it doesn't have to be. This can be its own separate crate. Like, there's Rebel ANSI color, that's its own separate crate. Rebel terminal async is its own separate crate. They all live within this monorepo of Rebel Open Core, but if you need to use it and you don't want to bring along Rebel 2e, just let me know. I'll be happy to separate this out into its own crate that'll live in this monorepo. So with that said, the main entry point for the parsing is MD_Parser. So that's the it's under the source 2e MD Parser folder, and there's a mod rs, which is this documentation right here. And there's really this entire universe of things that we're going into in this particular video is just one function, and that one function is this thing called Parse Markdown. And let me show you this function real quick. So this entire thing comes down to this one function. And what this Parse Markdown function does is, this is a nom parser, as you can tell, because it takes an input of type t and returns an I result. And there's the output type. Sorry, this is the remainder type, and that's the output type. So it converts or parses this string slice into some type, Rust type called MdDocument, and whatever it can't consume, it returns as a string. But actually, these parsers are set up in a way that you won't get any remainder. The remainder is always like empty string. So, remember I was telling you there was like a DOM equivalent that's called MdDocument, and it's a list of MD block. What's an MD block? Also, what's a list? So list is just a vec, and the only reason I made my own list, which has an inner field which holds a vec of type t, is so that I could implement the from trait on it, because otherwise because of the orphan rule I couldn't. So I just wanted to make this a much more ergonomic API, which unfortunately meant that I had to basically create a new type with just wraps vec so that I could do a from implementation and a whole host of other things just to make it more ergonomic, like there's add assign and a whole host of other things. But this is the main one, that why I needed to implement this or make a new list type. So MD block is the interesting one. So here, when we were going through, let me see, and I said that this one, and I said that was a heading. Well, this is that heading. A heading is has something called heading data in it, and the heading data has a heading level, and the level has a number. So this is heading level 1, this is heading level 2. And we're going to go through tests and stuff where we actually see the string slice being turned into an MdDocument, so you can see how that parsing works. And if for those of you familiar with like any kind of HTML parser or CSS parser, or even like a language parser, like if you've done any work with like IDEs and you've implemented a language parser for VS Code, it's the same kind of thing, where you take a string slice and that gets parsed, and then on the other end, the output or the return is a abstract syntax tree. So in this case, the abstract syntax tree is called list of MD block, aka MdDocument. I use a lot of type aliases because instead of creating new types, it just makes it easier to use type aliases. The documentation looks good, but I haven't necessarily created any extra types. Let's see. Okay, so the Markdown elements here, we have like headings, smart lists, text blocks. Text blocks have these things called line fragments. So these are basically the two most complicated things in the abstract syntax tree. You have like all the elements that make up the Markdown document at a high level, and at a deeper level, you have something called, this is for the text block. A text block is like anything in Markdown that is plain text. So for example, this is a heading. This is a list. This is a fenced code block. This is a list. Things that are plain text are these things. So essentially, if I were to just start writing some random Markdown, say this is text, and I can have a link. So I can say link, and I can put URL. I can put like foo. I can say, you know, bar, something along those lines. This is this thing, text. And it's saying that a text is made up of a list of Markdown line fragments and a line fragment. You can think of it as a span in HTML, if that helps, where a fragment can be a list bullet, ordered list bullet, plain text, bold, italic, inline code, which is inline code is like this, like that, a link, which we've done, image tag, basically we can do hyperlinks, image links, and checkboxes. So this is basically all of the stuff that you can see in sort of this one line would have to be parsed into this whole thing. So just in case you're wondering what's going on in MdLineFragment, it's whatever's in this. It's like spans or fragments, which are part of a line, Markdown line. That's kind of like the name of it. Okay, so that kind of gives you an overview of the types at a high level, and all the constants that are needed for parsing are in this one constants module. So it just makes it easy. And also, like if, for example, you want to change something fundamental in how the parser works, you don't have to change code. You can just come in here and change a constant. So like, for example, for bold right now, we use the star character. If you don't want like that, just make it star star. For underscore, for italic, we use underscore. If you don't like that, make it underscore underscore. So there's quite a bit of flexibility there in how this can be configured. So let's take a step back. So there's one function called parse Markdown, which has to take all of this string slice and turn it into this thing called MdDocument, which can be rendered, in this case, visually. So you're seeing the output of MdDocument, and you've seen, like, because, you know, it's just a string slice, you've seen the stuff I've typed. So let's do a deep dive into how this string slice gets turned into this abstract syntax tree. So the main thing is parse Markdown. So we're gonna spend quite a bit of time in that. But I also wanted to give sort of high-level overview or the strategy on how to think about this parser. Like, what's the mental model for this thing? Like, if you're going to make your own complicated parser, how would you go about it? And Nom really wants you to start by building atomic parsers and then build them up. So you can think of it as you have a whole host of atomic parsers which will match something, and if they don't match and fail, then some other higher level parser will kick in and try to match it, and if that doesn't fail, then some higher level will kick in. If that doesn't, if that fails, then another higher level one will kick in and match it. If any one of these actually doesn't fail, then you've matched it. And then depending on how you organize these parsers, you can then essentially tokenize your slice, or your, I don't want to say stream, but your slice of bytes. You can actually tokenize it and then put all these tokens together in the sequence in which they appear, and then that ends up being your final abstract syntax tree in this case. So if you've done any work with procedural macros, then there's tokens and token streams. It's kind of like that. Like, array of bytes goes in, and an array of token streams comes out the other end. So so with that sort of high level organizational thought in mind, the way in which this parse markdown function is actually organized is that this is reflected in the documentation here. So the parse markdown function really it just kind of breaks down into this combinator called many zero. It just means that grab zero or many of these until there aren't any left to get. I've gotten to end of input. That's what this is. And so the prioritization absolutely matters. Like the order in which you list this is of critical importance. And the way you think about it is that, okay, the thing that I put on the top is going to be what I call the higher priority, the highest priority parser. The thing on the very bottom is going to be the lowest priority parser. So the highest priority parser, what sets, I mean, why is it a higher priority? It just means that when the parser comes across this string slice, this byte array, highest priority parser will essentially match this first. And it'll be like, okay, if I see at title colon something, then this will be parsed into the title variant of MD block. So MD block is that type. And if you look at MD block, there is title. Title just wraps a string slice. And so basically what we're saying is that when we parse this, the title of this slice, this input, is untitled. So that's kind of like how this works. Then the next thing we look for is tags list. Then we map it to the tags variant of this enum, which is a list of string slices, which is basically like, okay, what are all the comma and then there's a whole thing about comma separating the tags, which is a different parser in itself. And then there's authors, which is this thing. Who are the authors? And again, this is a comma separated parser, which the authors, if you look at this, it goes list of string slice. So these are basically, there's a comma separated parser that parses these things. Then it looks for the date. It looks for a heading. It looks for smart lists. And what that means is when it finds a title, it'll parse this chunk as a title and then remove it from the input. So that means when we look, and we're going to look at the output of these parsers to kind of understand what all this means, because a lot of it, at least to me, isn't that intuitive, because it's kind of like it's almost like declarative. We're expressing to nom the prioritization of the functions, but it's kind of like many zero, like is a control flow statement in nom, I'm pretty sure. Let's see, there's also alt. These are like functional control flow. So if you look at the, let's see, nom, where is this? In some of these imports, they have like really nice names. Yeah, combinator, is that? Multi, oh, branch, okay. So this is like, things like alt, permutation, these are, according to nom, like these are called branches. Things like many zero, they are in the multi module. So this is combinators applying their child parser multiple times, and depending on what error is out, it ends up essentially kind of playing itself out. So whenever you see this many, it just means that whatever sequence of parsers in here are going to be run repeatedly on input. And if something matches, that part will be removed from input. And in this case, returned as part of this markdown document list, our abstract syntax tree. And then the remainder of the input will go right back into this many zero and continue until there is no input left. So that's how you kind of read this. And so the prioritization of these parsers matters, because this is like for any sort of input up until new line and or not. This is where parsers get very complicated, especially for Markdown, which is it's loose. It's not that tight. in how it specifies things. So a lot of it is left to interpretation. So it can get pretty confusing, which is why there's tons and tons and tons of test cases to basically put as many different types of input through the test cases as possible to validate that the parsers actually do what you think they should do. So we're going to spend a lot of time in this what I call the lowest priority parser, the parse block markdown text with or without new line. So what it does is that it tries to find a title. If it can't find it, it tries to look for tags, and once all that is exhausted, and at the very end it goes, okay, this must be some text, and so I'm going to try and see what's in it. I'm going to try and parse out the fragments that might be in this text, and typically in Markdown almost everything is delimited by one line. So it's either, you can think of it this way, like the input is sort of chunked into lines, and then for a lot of the parsing, the content, the characters from where you are until the next new line is basically your input, which is what this is saying, with or without new line. But then you can also parse something without a new line. So it's what I said doesn't always hold true, but that's sort of like something to keep in mind. And the docs actually talk about this. So the parsing strategy in most cases is to parse the most specific thing first and then parse the more general thing later. And then there's also this concept of new line, which I called EOL. You'll see in a lot of these function names EOL. Sometimes explicitly I'll say with or without new line, so that there's no confusion at all. But typically when there's a lot of nested parsers, it'll say like optional EOL. Basically, sometimes there's no new line and we simply use the entire input, or we go until the end of input, which I call EOI. So there's EOL and EOI. There's nothing past EOI. So once you hit the end of the input, you're done. You've parsed your whole document. So then one of the things that kind of was a little bit difficult for me to understand at first is that when you want a parser to say, okay, I don't want to parse this, in NOM, you just throw an error. It goes, you know what, this input is not for me, and what that does is it rolls back any changes it might have made, because the nature of functional programming, like you're just passing an input slice to a function. If the function doesn't return the remainder and the output, it will return an error, and if it returns an error, the input that was passed to that function is untouched. So that's another thing to get used to. It's pretty cool. So basically, if it errors out, it hasn't polluted the input. So the nature, the best way I can think about it is the recursive in nature, especially when you see like one of these many zeros. That's the easiest way in which I've thought about it. So in a lot of the code, you'll see like edge cases, just like you'd see in recursion. It's kind of like checking for preconditions for edge cases, and if they're not met, then it errors out before it tries to do any parsing. So essentially, this particular parser is the one that we are going to spend a lot of time on, and specifically this function. So you'll notice almost a recursive nature. Like if you look at this, the parse markdown is composed of these things. And when we zoom into parse block markdown text with or without new line, it kind of looks like that. If you kind of squint a little bit, there's no many, but there's an alt and there's a whole bunch of other parsers. So a lot of NOM looks like this. It's like what you see at the top level, you go one level deeper, looks a very similar organization, go a little bit deeper, very similar organization, and so on. So this is what makes it very complicated. It's and also very powerful, because you can just kind of like slice your problem into smaller and smaller sort of subtrees, and then each one of those subtrees will handle parsing some part of your final abstract syntax tree. So it's pretty cool separation of concerns, actually. But yeah, if you're not, if you're new to functional programming, then this might not seem so intuitive, because the high order functions show up everywhere. There's functions that return functions and functions that take other functions as arguments. So you just kind of have to get used to that. This is the lowest priority parser, this thing, parse inline fragments until end of line or end of input. This means that we're trying to match something that we typed in a line in the editor, and it's not a heading, it's not a list, it's not a title, it's not a fenced code block, it's just plain text. Or not plain text, it's just text. Because even though it says plain text, I mean, that was just so that I could disambiguate it from like fenced code block or something like that, but it should just be, you know, fragment text. You're extracting text fragments out of like a line of input, and a line is an input that's still limited by a carriage return line feed, and your whole input might have many different lines in it. So so basically, in this particular case, even when we're drilling down into what looks like a line of input, what we're doing is we are so let me show you this. So there is a many in there, and this is why I did this diagram, because otherwise it's just confusing from looking at the source code. Because if you look at the source code, it goes, okay, parse this thing, which is here, which actually has two variants. Each variant has a many. But let me highlight this for you. Each variant has a many. So this one has a many, and that one has a many. Wonder why. Oops. And so basically, like, it's not obvious from looking at this that many zero shows up in this function and that function, which is basically this thing has many zero, and it ends up calling parse inline fragments over and over again, because this thing then goes and calls parse inline fragments. And when you look at parse inline fragments until end of line or end of input, this thing, it's wrapped in a many, and inside of that we have a whole bunch of specific and generic parsers that run. So we run the higher priority parsers first to see if we can parse something out, and if that doesn't work, we go to the catch-all or the lowest priority parser. So, and I'm going to show this in the code because a lot of this doesn't make a whole lot of sense until we dive into the code. And so what this means is that when you give it this particular function, this is the let's parse a line of markdown text. This is when you give it a string slice and it goes, okay, foo, bar, baz. If you notice, this is bold, this is italic, this is hyperlink, and this is image. So we can parse it ourselves pretty easily. But so so basically, for this particular parser, it has to be able to extract these things like italic, bold, inline, code, image, link, and so on from this line of input, right? So that's kind of like what's happening here. And so the way it goes about its business is that it tries to see, okay, do you start with an underscore in the simplest case? And if it starts with an underscore, then it knows that it's italic. If it starts with a star, then it goes, okay, you're bold. So it basically grabs the underscore. This specialized parser starts with delim non-null. The way you read this is like, go take everything between two underscores from this input. And if there's a new line, then just where's the new line? So this is that function, there's the input, and it goes where's the new line? This one. So that ends up calling another parser. So this one goes, okay, if you parse something between two delimiters and you found a new line in there, go ahead and error out. So basically this whole thing blows up, and it basically won't, if there's a new line, this will error out. So that's why it goes, okay, parse anything in between two underscores, but if you encounter a new line, go ahead and error out. So That means the way you kind of understand this in English is that you cannot have something inside of an italic because it just wraps a string slice. This string slice cannot have a carriage return line feed or a line boundary in it. So in Markdown, if you say something like if you say star foo bar and then do baz, like it won't bold this whole thing. It'll just say that this is not bold and that is not bold. But if you put them in one line, then this is bold. So that's kind of like what that means is do not include new lines, and that's why it's so complicated. Is that it's like, okay, I'm gonna go get whatever it is in between a thing that has two delimiters, and it gets more complicated than that because there's like, oh, okay, does it start with a delimiter? Do you only have one delimiter? In which case it knows it's not going to find a closing delimiter, and so on. So it's if it goes, okay, you only have one delimiter because it's like star foo and that's it, then it goes, all right, I can't match it, so I'm just gonna like say error because there's no enclosing delimiter. It's there's no pair, it's just one. And it gets more complicated when you do something like with backticks, especially when you go backtick, 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 that means something. But then you can go backtick, backtick, that means something. And so you can go backtick, 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 4 backticks, and then 5 backticks, 6 backticks. You're like, okay, what is going on? Like, which is what? So because 3 backticks means start of a fence code block, 1 backtick means I'm looking for another backtick. So it can get very complicated very quickly. And so this parser is by no means perfect, but it's not. It's beyond like it's not in the early days anymore. Like as this evolves, it'll get more and more sophisticated, and I think a lot of these functions will have a lot of these edge cases that are baked into them, which is kind of nice. By separating the parsers into so many layers, it's possible to handle all kinds of edge cases in each of them. So that was like how you match underscore. Star works the exact same way. Backtick works almost exactly the same way, except that for backticks, this code actually counts the number of backticks, and if it sees 3, it errors out. It goes, you know what, this particular parser can only match something that has exactly 2 backticks. So that's kind of interesting, and they can't have any carriage return line feed in between the 2 backticks. So that's what this does, and that's why there's all this extra logic. If you notice that this particular chunk is generalized between all of these functions, and that's not by accident, it just makes it, otherwise it's just really hard to have to sort of make a new parser for every case. So if you go through the code and check out take, this is those atomic parsers I was talking about. There's like a whole atomic module in here where a lot of these parsers have been defined, and they're reused as much as possible. Sometimes it makes sense to reuse, sometimes not so much. So again, a lot of really good tests are necessary. So if we go back again, so the only way in my opinion to see what this works, what actually happens at runtime, is by running a test and then seeing the debug output to see what's going on. Because a lot of this, you know, even as I'm talking through this, it might not work the way you think. So, and I'm going to run through a bunch of tests. I just wanted to show you a bunch of these functions as they're defined, so we know what we're looking at when we look at the test output. So this is probably the most complicated parser in this entire code base. This is the thing that parses out a line of text and extracts fragments from it. I call it the catch-all parser. It's the lowest priority parser for parsing a single line of Markdown, parsing it into a bunch of fragments or spans. So things like, you know, go find me all the italics, all the bolds, all the inline code, all the image tags, all the link all the image tags, all the link tags, all the checkboxes. And then if none of these match, then go run this parser. And remember now, this is run in a loop. So there's many 0. This keeps going over and over and over again. Let's look at this one. parse fragment plain text no new line, which is this here. It's called a catch-all parser. And the job of this catch-all parser is to basically take a line of text that you've typed in and map it to the text variant, this thing, text, this one. So and the text can have inside of it like plain, variant. It can actually, let me show you. The text can, sorry, so the Markdown line fragment, it can have the text block can have a bunch of Markdown line fragments in it, where this thing text, and it can have, like, you know, plain text, bold text, italic text, inline code text, link text, image text, and so on. So that's like what this thing is going to produce as output. So basically this thing gets mapped to MD block text. So that's kind of like how you think about it. So there's a lot of sort of mapping happening from string slices into types. So where is the, which one was it called? This one, parse. This one. So here, yeah, as you can see. So it's kind of two layers of mapping. So you have like MdLineFragments that are many zero, basically takes a bunch of these, puts them in a vec, sends it off to MD block text, which then puts it inside of MD block text. So that's how this wrap up happens. And we'll see this when we look at the abstract syntax tree dump to standard out. So the way this plain text parser works, which is the lowest priority parser, this thing, it basically like tries to see if there's any special characters in the mix, and if there is, then it splits the input at that special character and goes, you know what, I found some text. So it goes, okay, whatever your special character is, it splits it in two. There's the I think I call it the before and the after. Yeah, the before part and the after part. So wherever the split is, there's a before part and an after part. So the before part gets returned as a plain. So basically, if we look at this, the before part gets returned as MdLineFragment plain, and the after part gets handed back to this parser, and then basically puts it through this whole logic again. So that's how this works. You basically get as much as you can, return that as, okay, I found some output, and then the remainder is then put back into this sort of loop until there's nothing that's left. They could have all aired out, or the input is finished. So this is basically how this kind of is put together. So so this function gets called over and over again. So whenever it returns something, it'll get sent back up to this sort of sequence of parsers. And so when it returns something, an error, or it returns a result, it will end up back, the remainder of the input will end up going through this whole flow again until one of these matches or errors. You know, if it errors out, it keeps going until it matches. And then when it matches, then it goes, okay, whatever the output was is now plain, and whatever the remainder of the input is will go straight back into this sort of sequence. So it keeps getting called over and over and over again. And let's see. So this one, it basically looks for special characters, and if it finds them, then it splits it and it goes, all right, I've understood as much as I can. whatever I can't understand, I'm going to send it back so it can get parsed as something else. That's a general idea. There's a whole host of edge cases where when a special character is matched, it breaks it until the special character. And I'll show you what this looks like in a test in just a minute. And so the remainder of the input actually now begins with the special character. So then different logic kicks in if the input now begins with a special character, because then if that special character like underscore, if it has a matching underscore, we found an italic fragment. So that has to be accounted for in here as well. So it gets pretty complicated. So so if it matches, so actually if it matches, if there's a underscore and an underscore, it'll be handled by this parser because it's higher priority. So this parser might end up producing a remainder that will then be consumed by this parser, and it will generate a fragment, an italic fragment. So let's see this thing in action. So here we have a bunch of tests, and let's see, this one is doing the inline fragment. So this is basically like, you can think of it as you have a line of text. For a full Markdown document, we will probably want to run this one. There's tests for this one as well. So so let's do the lowest, the sort of the line level tests first. So here we have, let me just walk you through some tests real quick. So this one, I'm going to walk you just from the top, why not? So this is in the same file. So let's see, in order to sort of see these tests doing what they're supposed to do, one thing that you have to do is you have to go to this mod.rs file, and you have to turn this to true. Debug MD Parser standard out, and I'm going to leave a little note here to clean this up, clean up. And so what this does is that in these tests, it will enable really nice standard out, so we can see like what the heck is going on. So for example, let's say that I have this function parse fragment plain text no new line. We've been looking at it. This is the lowest, so what I call the lowest priority parser. And if we just feed it a line, this underscore bar, what happens is that once you call the function, you'll get, by the way, this is the remainder and this is the output. So that's how you read it. It's kind of backwards. So basically what this means is that this particular thing returned a string slice called this space, and whoever called this, parse fragment new line. So if we look at who calls it, it's going to map it to MdLineFragment plain. That's kind of like how you understand this. So this is just dealing in string slices because we're at a really low level, but when you kind of zoom up one level higher, this catch-all parser, if you see this, that gets mapped to this thing called text. And then here, each one of these smaller parsers gets mapped to some other MdLineFragment. So I should probably put down the diagram here that this maps to MdLineFragment. I mean, you can see it in the code, but that's definitely missing from the diagram. I'll add that later. So here you can see like these are all the sort of the types that emerge from calling this function. But we're not, let's see, MdLineFragment right there. So, but because we're not calling this function, we could. There's other tests for that too, but we are currently looking at this one. Hopefully that makes sense. They all sound very similar. So we will actually run through tests for this one as well. That's like next. So if we look at this one, So here you can see that this space underscore bar gets split this way. This is interesting, underscore bar, because when a particular line begins with underscore, it's handled differently. It actually gets split into the remainder is bar, and the output is underscore. And similarly, something like that happens here. So that's kind of neat. So let's see. When we look at this one, a more interesting test actually is this higher level one. Let's see what the tests look like when we parse this. So there's this thing called checkbox parse policy. For now, just ignore this. Just it's got something to do with syntax highlighting, but just for the most part, ignore this field and just assume it says ignore ignore checkbox. And so when we run this test, what it will do is that it will parse this string and it'll split it and return an MdLineFragment, which is plain. So basically, if that's what this does. So if I run like here is bold and they're both bold, it'll come back with bold. So let's run this real quick so we can just see temp, just so we can see this part of it. Actually, let's do this. So when we run this, and you can actually put this through the debugger and see what the heck is going on. So I wanted to show you this. So here we can see, remember when we said that debug thing to be true? We got this output where it goes, for the input, here is plain text. These are the specialized parsers that are running. So it's kind of like you can put the code side by side and you can kind of see what's happening. So this function ends up calling all these different parsers. And essentially, so essentially the first thing that happens is it looks for an underscore. So it goes, okay, specialized parser is running, and the delimiter is underscore, which is why it's checking for underscore, and goes, all right, I found no underscores here. And it goes, okay, this parser does not match because it generated an error. That's what these two red dots mean, or red hexagons. So then it goes and runs the next one, which is star. And you can see that happening here. Specialized parser, here's plain text, delimiter star. It goes, okay, I haven't found any. Okay, error out. Fantastic. So then we go to the backtick. And it goes, all right, specialized parser, there's plain text, looks for backtick, and goes, all right, cool, I haven't found any, errors out. Then it looks for left image, left link, checkbox. And these actually just look for, it's not using this specialized parser function, which is why you don't see any output, but that might be useful actually to put some output there. But yeah, actually I will put some output there. Why not, to make this consistent? So when these parsers run, they're running silently. You don't really see them, but you do see this last one, this one. It's got this strange purple thing. It goes plain parser. Input is here is plain text, and it goes, okay, the output is here is plain text, which results in, where did we go? Which results in MdLineFragment plain, here is plain text. So that's kind of like how you sort of read these things. So we can actually do the same treatment for, let's say, bold. Bold would match on the second parser. Let's see if we do bold. Actually, I can say, leave some notes here. I need to put probably add debug output for flag. Yeah, because if this flag is true, then it should really show debug output to match the other parsers, because otherwise it seems like something is missing. Let's put it here, and we can put that here. Okay, so let's go back to where we were. Where's the test? I think it was like test temp or something. Yeah, there it is. Okay, so we were here and we were checking on bold. Let's see, bold. So when we run this test, by the way, when you run this through a debugger, that's also a really good exercise. For debuggers, I recommend using Rust Rover. It's actually a much nicer debugger than VS Code. I use both. So I have Rust Rover here. So I can run the code in here through debuggers, basically. So this is much nicer. Okay, where were we? Okay, so here we had the input. Here is bold. This is an easy one because we know that it's going to match bold because it's neatly delimited by star. And here it's checking for underscore because that's what it does. If you look at the first parser, second parser is star, and it goes, oh, look, count is 2. Boom, it matched. And it returned actually this one should also, it should, this one, I should really put in here an action item to this one, because otherwise it's missing in the output. You're supposed to see a little nice visual, you know, like a little thing saying that, oh, look, it's returned the output. But okay, I'll put that in there. But essentially, it matches with the bold, and you end up with, you know, MdLineFragment bold. So these are some of the simpler ones. Where it gets more complicated is where there's strange, like, underscores and italics and stuff like that. I can show you some of those. Let's see, where is it? Oh, I think I have those in a different test case. So now that we've seen this, let's see, I think this is the one. Yeah, this is the one with all the strange stuff in it. Like, no, this is not the one with strange stuff. This the one with strange stuff. There's so many tests. I think it's this one. Backticks, stars. Let's see. I don't think it's going to be, well, let's see, parse inline. Let's look at all the tests to see which one, because I'm looking for a specific test where it comes back as a much more complicated, let's see, output. I don't think it's in this one. I think it's the one that's called by this one. Yeah, I think it's this one. So now we're at the very top level. So we've kind of jumped up from here. Jumped up from here to here. Parse block markdown text with or without new line. So this is the one that was called by the very, very top level parser. So this is one where all kinds of interesting stuff, because this is the one that returns those MdLineFragments. So this is the one where there's a lot of interesting tests. Let's see. Where are those interesting tests? Here we go. Okay. So here's an example. These are all those strange things that you can see. Like this is here's the input. This is underscore hyperlink colon foo. It's like what? Because this is not this is a hyperlink, but this is not a valid italic. So this is where this parser really, like, its complication shines through. Where how it parses it. Let's run it and see what happens. As you can see, quite a few parsers ran. Like, this is not trivial. Look at how much output there is compared to the other stuff. And as you can see, like, this particular code path, where the heck did it go? This one. You can see it being run over and over and over again. This is kind of like what I'm talking about. So let's walk through this just as an exercise. So we have the input is this is underscore hyperlink, and it's checking for underscore. It goes, yep, I found an underscore. But it goes, yeah, but I didn't find an enclosing underscore, so this is an error. I'm not gonna match it. Then it goes, oh, okay, let's look for star. Did I find a star? Nope, there's no stars, so it errors out. Backticks, no backticks, it errors out. So far, so good. Then it goes, oh, now it's basically these are silent. I need to fix these, but they need to produce some output to show this kind of thing. Like basically, okay, this is what I'm doing. I've errored out or I've succeeded. Finally, it goes, all right, let's do the the lowest priority parser, this one. And it goes, oh, okay, this is a hyperlink. And it goes, oh, I was only able to parse up until here. This is a. And then it splits the input an underscore hyperlink and sends it right back to this parser. Because it's like, well, maybe there's other things that, you know, after this hyperlink, maybe there's another hyperlink. Maybe it's like, well, maybe after this underscore, there might be another underscore. I don't know. The only way I can know that is if I send it back. So it sends it back. And then it's like, okay, then it's like, this is gets, it says normal case. This means it returned this as this MdLineFragment plain. So whenever you see those returns, it maps to one of these in the output. So then it goes, all right, run the parser again, this whole thing again, but now starting with underscore hyperlink. So it basically checks for closing underscore. It can't find it, can't find star, it can't find backtick. So then it goes, okay. Then it hits a edge case and it pulls out the underscore as an output and returns the remainder to this parser. So this produces this thing. So underscore gets pulled out as a plain fragment as well, as what I was trying to show. So this is a space, that's one slice of plain. Then there's another slice of plain, which is underscore. Then there's another slice after that, which is this hyperlink thing. Because it goes, I can parse until hyperlink colon, and then this I don't know about, that looks like a special character to me. And it goes, okay, you can see it right here. It goes, it's splitting the input. It goes, okay, I'm going to parse hyperlink, blah, blah, blah. Hyperlink colon space is plain, and the remainder is just give it back to the sequence of parsers so they can make heads or tails out of it. And that's how we get this. And as you can see, the abstract syntax tree element after that is a hyperlink. So this one, when we look here in the sequence of parsers, we'll see now the input is foo. This looks pretty cleanly like a hyperlink, except it's got an extra dot at the end of it. So what will happen is, we won't see this here because all of a sudden the input becomes dot. It's because what happened is that the specialized parser for hyperlink actually succeeded, but it did so silently, and it generated a link, which you can see here. And finally, the remainder dot goes to that same sort of sequence of functions and ends up returning okay with a dot. So all right, that's the final, and then it errors out. And then when this final error happens with end of file, this whole parser goes, okay, I'm done. There's nothing for me to do. Remember, this is called by many zero. So many zero wraps up and it goes, all right, I will give you a vec of these MdLineFragments, and then it converts that vec into a list. Whew. So that's basically what is going on here, if you want to. So that test is actually a really good one to go through. Actually, I'm gonna make a note here and say these are really, really, really good tests to walk through. This is to understand how a single line of Markdown text is parsed. Because there's so many different parsers and there's so many different priorities and so on. And this is just the sort of the branch that's handling plain, like the quote unquote text, the fragments inside of a line. There's more parsers, like there's this title value thing, tags list, authors, date, heading, smart list, code block. Each one is like kind of a universe unto itself, but surprisingly they're not as complicated as this one. This one is the strangest one with the most number of kind of corner cases, so I wanted to cover that in this video. So hopefully you found this useful. I'm gonna create a blog post with all of this stuff in it. I know it's very heavy and it's very dense, but for anybody writing a real parser, I think this is kind of like what you have to expect, and this gives a sense of how many kinds of the sort of extensive tests that you might have to do. So yeah, with that, I'm going to wrap this video. If you like this video, please give it a thumbs up and subscribe to the channel. That way you'll be notified when new videos are dropped. And then check out developerlife.com as well. I'm going to make a new blog post about this particular one because this is not the comprehensive guide to nom parsing. That was just kind of nom basics. Believe it or not, this is like how do you actually use nom in the real world in a real parser. So this one's going to come out later on today, and then I will update Eddie. That's this thing that I was showing you. Eddie, that one's going to be using this new parser. I think it's going to be Rebel Commander version 0.0.14. So yeah, definitely do a cargo install with Rebel Command. This one, cargo install Rebel Commander to check out Eddie. When it's launched, play around with it. Let me know if you see any bugs. Play around with Giti. That's another good one. And then yeah, check out Developer Life. Please subscribe as well. We have a newsletter, so whenever there's new content, whether it's a video or associated blog post, you'll hear about it from there. So thank you again for watching this video, and I will see you in the next one.